All right, hi everyone. How are you all doing? So today we have another Codeforces round, and today is a Div1 plus Div2 round. So yeah, I will be participating in this, and yeah, it will be rated for me. So yeah, let's see how this one goes. And yeah, I haven't been posting screencasts from a very long time, and the reason was that my internship drive was going on. So yeah, I was busy with that. But yeah, today, let's see if we can have a screencast if everything goes fine. And yeah, today I have included something new in this whole setup. So we also have a keyboard cam now, and you guys can see how I actually type. And yeah, so how do I actually have two cameras now? Because I recently bought a new webcam. So you can see the improvement in the quality of FaceCam. So that is basically because of the new webcam. And yeah, also the contest is of 2 hours 30 minutes. So it will be a pretty long contest. And yeah, I hope Sublime is fine. So it seems to be fine. And yeah, there is some background noise at my end because, the food is being cooked at my home. So yeah. And yeah, let's see if I can get back to candidate master in this one. Okay. So let's just quickly look at the number of problems that we have here. And we have a lot of problems. Okay. 9 problems. Let's define Sx to be the sum of digits of number x written in decimal system, for example. Okay. We will call an integer x interesting if x plus 1 is less than sx. In each test, you will be given one integer n. Your task is to calculate the number of integers x such that. Okay. So if the last digit is n, if the last digit is 9, then this is definitely happening. Okay. So for 1 it is 0, for 9 it is 1, right? For 10 it is 1. For 34 it will be all the digits that have 9 as their ending digit. So that should be simply just n plus 1 divided by 10. I think that should be fine. We don't even need to take the ceil or the floor value in that case. I mean, the floor value should do. So yeah, let's see. And this is fine. If I just include a 1 here, I mean a 9 here, then this is also one of the answers, so it should be 4. So this is fine. And yeah, the range of n is fine as well. Yeah, this should be fine. Okay, great. So we're done with the first problem. Moving on to the next one. So you have a string s and a chip which you can place onto any character of the string. Okay, after placing the chip, and let me see if I have started the recording. Yeah, I have. So after placing the chip, you move it to the right several times, possibly 0, maybe 0. You perform the following operation several times. If the current position of the chip is I, you move it to the position I plus 1. Of course, moving right. After moving the chip to the right, you move it to the left several times. You perform the following operations several times if the current position of the chip is I. Right. When you place a chip or move it, you write down the character where the chip ends up after your action. For example, if S is this, you place the chip onto the third character, move it to the right 2 times. Okay, so we have C, D, E, then we have D, okay, D, C, B. Right, because we moved it 3 times to the left as well. You're given two strings S and T. Your task is to determine whether it is possible to perform the described operations with S so that you write down the string T as a result. Okay. So if I'm on the ith, basically if I'm on the ith character in string S and on the jth character in string T, then I basically have two choices. Either I can move towards the left or towards the right. Okay. Move it twice to the right, then move it twice to the left. Move it. Okay, can we also do this that we move towards the right, then left, then right again? Okay, after moving the chip to the right, you move it to the left several times. You perform the following operation several times. If the current position of the chip is I, you move it to the left. You move it to the position I minus 1. Okay. So here if we look at this string, this is the first test case, this is the second one, this is the third one. Right. So if I just do B, A, A. Oh, okay. So we can only move towards the right once and then move towards the left once. Right. So let's say I start on the index I and I move towards the right, let's say k times. Then I will have to move towards the left. Right. Okay, so this would be something like n cube here. Yeah, n cube should be fine, I think. Right, so we can start on any character that we like. Okay. So if s at I is not equal to t at 0, then I just continue. I don't really care about this one. Else, for int j equals to I, j is less than n, j plus plus. Okay. So here I take the ith character. So if s at j equals to t at covered, right? If this is the case, int left equals to m minus covered. Else we just break because we cannot go further here. So we do covered plus plus, and these are the elements that are remaining. Okay. And how many elements are towards the left in the string s? Equals to j. Basically we'll have j characters towards the left. Right. So if here is less than equal to left and s dot sub str. Okay. Also, if so if let's just put it here, or I can put it here as well. If covered equals to m, then I basically know that I found my string. Right, okay, so now this is fine. Here is less than equal to left. It should be actually greater than equal to left. String rev equals to s dot sub str, and I have so I'm standing on jth index, so I do j minus left, comma left. Right, now I only need to check if this is actually equal to the remaining string or not. So if rev equals to what? T dot sub str. So how many characters we've already covered? We've covered j plus 1 characters here. And then we have m minus. If we've covered one character, then we have then I just simply do found equals to true break. Right. Right, let's test it here. Okay. So if covered equals to m, then I do found equals to true, and then I break, right? If s at j equals to t at covered, then I do covered plus plus, and then I have int left equals to m minus covered. Okay, so if covered we don't need this here. Okay, I think there is another issue. So here equals to j. It basically means how many characters are left towards the left side in string s. So if here is greater than equal to left, j minus left. Right. Sub str. Okay, this shouldn't be j. This should be covered. And this should be left. Okay. So in the last one, I'm getting a yes, and I should be getting a no. If covered equals to m, it should be. So now I think it is working fine. Let me just read the code once again. So I have string st, I found the length of both of these strings, and then I've maintained a variable which says I haven't found the answer. So if I find it, then I simply break. and this is like the very first line. So we don't need this here actually. Okay, there is some other issue now. Let's just keep it. So int covered equals to 0. If s at j equals to t at covered, then I do covered plus plus, right? If covered equals to m, that means I found it, then I return. I mean, I just break. And then left is the number of characters that I still need to find. Here equals to j. J is the number of characters left towards the left side of string s. And then I find this substring, I reverse it. Right, this should be fine. Okay, cool. So the pretests have passed here. Okay, moving on to problem C now. And it already has 171 submissions, which is great. So consider a simplified penalty phase at the end of a football match. A penalty phase consists of at most 10 kicks. The first team takes the first kick, the second team takes the second kick, then the first team, okay. The team that scores more goals wins. If both the teams score the same number of goals, the game results in a tie. Note that it goes against the usual football rules, okay. The penalty phase is stopped if one team has scored more goals than the other team could reach with all of its remaining kicks, right? For example, if after the 7th kick the first team has scored 1 goal and the second team has scored 3 goals already, so yeah, you cannot catch up because you only have 1 kick remaining, right? Okay. The first team cannot reach 3 goals, right? This is right. Okay. You know which player will be taking each kick, so you have your predictions for each of the 10 kicks. These predictions are represented by a string s consisting of 10 characters. Each character can either be 1, 0 or question mark. This string represents your predictions in the following way. If si equals to 1, then the ith kick will definitely score ith. Okay. Right. Could go either way. Okay. Based on your predictions, you have to calculate the minimum possible number of kicks there can be in the penalty phase. That means the earliest moment when the penalty phase is stopped, considering all possible ways it could go. Okay. Note that the referee doesn't take into account any predictions when deciding to stop the penalty phase. You may know. Okay. In the first test case, consider the situation when the first, 5th, and 7th kicks score goals, and 2nd, 3rd, and 4th, 6th are unsuccessful. Then the current number of goals for the first team is 3. For the second team is 0. Right. So can't I just run a very simple recursion here? That would be 2 to the power n, considering all possibilities. 2 to the power 10 basically. So I think I can do that. So 0 is basically the index, then the 0 is the number of goals scored by the first, the number of goals scored by the second, and then these are the kicks remaining. Right. Okay, int f, int s, k2. Right. So if index equals to 10, then we are done. Then we just return 0. Now if okay, so if s minus, okay, let's just see if the first team is losing or not. So if f plus k1 is less than s, then you return 0. So if s plus k2 is less than f, then you return 0 again. Now if s at I equals to 1, then we know that whoever's chance it is, he will be scoring a goal here. So if index modulo 2 equals to 0, then I do f plus plus and I do k1 minus minus, else I'll do s plus plus and k2 minus minus. So here we'll be just passing index plus 1. Now we'll be considering this case where s at I equals to 0. That means there is no goal scored here. Okay, so here I'll just do k1 minus minus, and here I'll just do k2 minus, okay, k2 minus minus. Else I'll be just considering both possibilities. So if index modulo 2 equals to 0, then I'll do return, okay, I'll just have to do return 1 plus. So I'll be calling helper. I'll do f plus 1, I'll do k1 minus 1, I'll do k2 and s, and I also have to pass s here. Right, else I'll be just doing the same thing again. Oh. K2 minus 1 and s. Fs and k1, k2 minus 1 and s. Right, so this should be fine. Okay. Conflicting declaration of S. Oh, okay, this should be S1 at index So I have 7, 10, 6 and 9. This should be fine. Let me just test the base cases. F plus K1 is less than S, okay. S plus K2 is less than F. Right, this should be fine. Okay, cool. Okay, let's look at the fourth problem then. So this was a very simple problem. I don't know how do they even have such a problem in a contest, because it is basic recursion here. So you're given two strings here, S and T, both consisting of lowercase English letters. Okay, yeah. You're going to type the string S by character from the first to the last one. When typing a character, instead of pressing the button corresponding to it, you can press the backspace button. It deletes the last character you have typed among those that aren't deleted yet. Or does nothing if there are no characters in the current string. Okay. For example, if S is this and you press backspace instead of typing the first and the fourth character, you will get B and D. Okay, if I press backspace, then I don't get an A here. Then I press B, C, B, and if I press a backspace again, then B also gets removed. Okay. And you press backspace instead of the last two characters. So I have A, B, C, and then yeah, BC will be removed because of two backspaces. Your task is to determine whether you can obtain the string T if you type the string S and press backspace instead of typing several. Okay, your task is to determine whether you can obtain the string T if you type the string S and press backspace instead of typing several. Oh, okay. In order to obtain BA from ABA, what you can do is you can do a backspace, then you can insert BA, then you can do a B again and then press a backspace. Okay, there's no way to obtain BB from. So a thing here is that, you know, we can only obtain T if it is a substring of S. We cannot obtain it otherwise. Or can we? No, I think we can, because even if we press a backspace, we can, yeah, again get it. Okay. Okay. So where is the old OneNote? Yeah. So if this is S and let me just make it here. Yeah. So if this is S, let's say, and this is T. So let's say I want to start from this character. I can do this by pressing backspace so many times and I include this character. Now this character is present here. Right. Now let's say I want to pick up this much substring. So this will be present here. And now let's say I want to skip these characters. And then I want to do something after that as well. So if I want to skip these characters, I will have to press backspace. So when I'm on this character, I can press a backspace for this one. Okay. So if there are basically n characters here and I want to remove k out of them, the last k, then I need to press backspace k times. So these k will be removed from here, but the next k characters will also not be included. right? So clearly if I press backspace k times, then the next k characters won't be included and the previous k characters won't be included as well. Right, so for any k, the number of characters that we're removing are basically even. So I can choose a substring from here, then I can remove even characters from here. And then I can choose a substring from here again, remove even characters in middle, and then start the substring again. Okay, so here is what I need to do. I have string s, I have string t. So from the very start, I can remove any characters, odd, even, that is totally my choice. But as soon as I start the string, then I can only remove even characters from here, then even characters from here. And the last one, if it is even or odd, it does not even matter. Okay. So I only need to tell whether it is possible or not. This can be easily done with a DP, but we cannot do an order of n square DP here for sure. Okay, let me think about this. Okay, so I think I have an approach here. So we can look at this problem in a completely different way. So instead of going from S to T, if I can go from T to S, that would also be the same thing. So here I have the string T, and here I have the string S, let's say. So this is T and this is S, and I start from the back. So what happens is that, whenever I'm removing characters, I can only remove them in pairs. So the thing is that if I start from the very end, let's say I have an A here and a B here. So this clearly means that, my string cannot, from going from S to T, I will have to remove B. So if I have to remove B, I will have to remove one more character because all of these characters are removed in pairs. So clearly if there is, let's say, an A as well here, I cannot take it because both of these need to be removed together. So what I can do is, I can just put a B here and an A here. So in the string T, I just include an AB here, and I have moved even number of characters. Now if I find an A, I can pick it. So the thing is that there are two choices basically. Should I pick it or should I not pick it? So why would I not pick it? I would not pick it if I get an A after that again, and that is also at an odd position, and we can form the string T after that. But the thing is that if I find this A at an odd position and this is also at an odd position, that means I can remove even number of elements in between. So ideally, if I just go greedy from the back to the front, this should work. And I just have to remove even number of characters. So do I also get the length of the strings here in the input? No, I don't. Okay, so while m is greater than 0 and n is greater than 0. Okay, so if s at t at m minus 1 equals to s at what? S at n minus 1, then I can just include this, right? So what I do is I do m minus minus, I do n minus minus. Else I'll just have to do m will be remaining the same and I'll just do n minus equals to 2. So if m equals to 0, I'll just do yes. else I do no. Okay, this should be, let's just do a test. Now what is the issue? Okay, so we have yes, no, no, yes, so this is fine. Okay, cool. So this was actually a very nice problem. Like just noticing that if you press the backspace, you have to remove 2 characters. This was pretty cool. Okay, looks like not a lot of people are giving today's contest. Okay, looking at problem E now. So problem E only has 62 submissions till now. But we have a lot of time to think about it. An identity permutation of length n is an array, okay. We performed the following operations on an identity permutation of length n. First, we cyclically shifted it to the right by k positions. Shifted it right by k positions where k is unknown to you. Okay. The only thing you know is that k is less than equal to 0 and k is greater than equal to 0 and less than equal to n minus 1. When an array is cyclically shifted to the right by k positions, the resulting array is formed by taking the last k elements of the original array and then appending n minus k elements to the right of them. Okay, yeah, this is fine. Secondly, perform the following operation at most m times. Pick any 2 elements of the array and swap them. You're given the values of n and m and the resulting array. Your task is to find all possible values of k in the cyclic shift operation. Okay. An identity permutation is this. We perform the following operations to an identity permutation of length n. First, we cyclically shifted it to the right by k positions, which is fine. And yeah, secondly, we performed the following operation at most m times. Pick any 2 elements of the array and swap them. Okay. You're given the values of n and m and the resulting array. Okay, your task is to find out all possible values of k in the cyclic shift operation. Right, first print one integer r, the number of possible values of k. Okay. So in the first test case, if we shift this whole permutation by 3 towards the right, we get 2, 3, 4, 1. Okay, fine. Then we swap the third and the fourth character. Okay. So this is very tricky. Okay, so basically answer is if you consider those m swaps, if you just reverse them, right, we can basically swap m pairs now. So if we just swap them and we get to a permutation, I mean a cyclically rotated permutation, that is one of our answers. Okay. At most m times. So this is at most m times. We can also do it less than m times. Right. Okay, let me think about this again. Okay, so here the thing is that if I have a permutation that is cyclically rotated, and if I fix the very first integer, let's say it is 5, and I know the permutation's length is of, let's say, 8 characters, so I would be having this, right? 5, 6, 7, 8, then I would be having 1, 2, 3, 4. Similarly, if I fix the first character to be, let's say, 8, then I know my next characters would be this, right? So now if I fix my first character, then I basically have to convert the given array to this with minimum number of swaps, right? But that would go order of n square even if we know the answer somehow. Even if we know somehow how to calculate that quickly. So let's just see swaps to convert. Okay. Okay, but are we only allowed adjacent swaps in this one? For adjacent swaps, the answer is obviously the number of inversions. But here we can swap any two elements. Okay. Okay, I cannot do this because obviously just finding it would take order of n square. There might be some other solution to this. Okay, if I know that 8 has to go on the position of, let's say, 1, and 1 has to go on the position of 5, and 5 has to go on the position of 6, and 6 has to go on the position of 8. Okay, so clearly if I just swap 1 and 8, and then I swap 1 and 5, and then I swap 6 and 5, so that should put everything in the right place. So here if we have, let's say, a cycle, this is the cycle, and how many elements are there? Let's say there are 2 elements, so we need 1 swap. If there are 3 elements, let's say 1 wants to go to 2, 2 wants to go to 3. Okay, so basically there will be a certain cycle for every, swapping. So clearly if I just swap these, I'll get 2 and 1, and then I can just swap these, so I'll get 3 and 2. But let's say I have something like this. I have 1 goes to 2, 2 goes to 3, 3 goes to 4, 4 goes to 5, 5 goes to 6, let's say, and 6 goes to 1. Okay, so if I just swap them, then I get 2 and 1, and then I can swap these two, I get 4 and 3. Then I can swap these two, I get 5 and 6. So here I've used 3 swaps till now. I am allowed to use 5. So now I can just do this. So I have 4 here and I have 2 here. So 1, 2 and 3 are in the right place, and 5 is also in the right place. But then I again have to swap this. So like 5 swaps would be needed. For a cycle of n minus 1, for a cycle of k, we need at least k minus 1 swaps. So this is a cycle of length k, we need k minus 1 swaps here. Right. But let's say I have right now 1, 2, 3, 4, 5, 6. So clearly 1 wants to go to somebody's position, let's say 3. 3 wants to go somewhere else. But there will be many cycles here. That is the whole point. So if I can somehow maintain these cycles efficiently and change them, then I should be done. Right. So let's say our first string is 1, 2, 3, 4, 5. Let's consider an example here. We have 1, 2, 3. Okay, let's consider some other example. Let us consider this one. 2, 3, 4, 1. So I start with this 1, 2, 3, 4. And I have 2, 3, 4, 1. So basically 1 needs to go to 2. And if I talk about 2, 2 needs to go to 3. Then 3 needs to go to 4 and 4 needs to go to 1. So this would require 3 steps. Right. Now if I, let's say, just move to, if I consider this permutation now, this cyclically rotated permutation. Okay, so this permutation was something different. We have 1, 2, 3, 4, and we have 2, 3, 1, 4. So 4 is already in the right place. We don't need to correct that. And we are allowed 1 swap. Right, so 1 needs to go to 2, 2 needs to go to 3. So that ultimately requires 2 steps, so we cannot do that. And let me choose a different color here. But now let's say we are concerned about this permutation 2, 3, 4, 1. And we have 2, 3, 1, 4. So clearly this just requires this to be swapped. Right. But how do I maintain this? Like I have something like this, and here it was 2 3 1 4. So the edges were something like this: 1 goes to 2, 2 goes to 3, 3 goes to 1. But as soon as I change this whole thing, 2 is on the right place, 3 is on the right place. Okay. M is less than equal to n by 3. So if we have smaller cycles, it would be better for us. Like if we have a cycle of length 6, then we need 5 swaps. But if we have 2 cycles of length 3, then we only need 4 swaps. Right. So we can only do n by 3 swaps. So if we have, let's say 6, then we can only do 2 swaps. So either we can have 2 cycles of length 2, or we can have 1 cycle of length 3. Two cycles of length 2 or 1 cycle of length 3. So some elements would be at the right place here. So if we start with the identity permutation, then everybody is on its right place. Now if we just cyclically shift it by 1, then all of these positions become position plus 1 modulo n. So we need to see how many of them are already on the right place. Okay. So even if we have all the cycles of length 2, so we can have at most 2n by 3 elements. Yeah, we can have at most 2n by 3 elements which are not at the right places. So at least n by 3 of them should be on the right places. Okay. So if I just say that n by 3 of them should be on the right place, then if n is big, so if, right, so even if I fix one of these elements, the whole permutation, I can know what is the permutation. if I just fix one of them. Okay. So I need at least n by 3 elements to be on their right places. So that is actually a very big claim here. So from the 10 elements that I have, let's say I have 10 elements, then 3 of them should be at the right places. So if I just pick one of them and I see along with this number how many others are on the right place. So that just makes up one combination. And this should be greater than n by 3. Okay. So in total, I am not, making a lot of changes here. Like I am not trying it out many times. I want n by 3 elements to be on the right places. So let's say I have this whole pool of numbers, and let's say all these numbers n by 3 are on the right place. So what I can do is I can just pick one of them, and as soon as I pick one of them, all the other positions get fixed. So clearly I will know all the other numbers that are already on the right places. So this would be like a group here. And if the length of this is, let's say, less than n by 3, then I can just skip it. And why can I skip it? Because yeah, the number of elements that are not on the right places would be greater than 2n by 3. And yeah, for even if we have two elements, pairing up, then the maximum number of swaps that we can do is n by 3, so that wouldn't work. So clearly this whole group must be n by 3, must have n by 3 elements. And if it doesn't have it, then we can try out the other elements. Right, but after we are done with this one, we can just remove all the numbers that were on the right places. So at least n by 3 should be on the right places. So for example, in this test case, we have three answers: 3, 0, 1, 2. 3, 0, 1, 2. And yeah, we were only allowed one swap. So one of them can be on the right place, while the other two can be on different places. So if we talk about 3 to 1, then 2 is on the right place here. Then in this one, yeah, in this one 2 is on the right place, in this one 3 is on the right place, and in this one 1 is on the right place. Right, so we need at least n by 3 elements to be on the right places. Okay, now let me think about it. Group these numbers accordingly. So I have int n comma m. Right. Now so now we'll have to see how many times is this number off by where it had to be. So int position equals to arri minus 1. This should have been the actual position of this number, but now it is at the position I. So what we want is I minus pos. Right. So if I is greater by 1, then I get 1. But let's say it is at the end. Okay, so this should be fine. So here I have ARR type. Right. So let's just debug this offset and the positions. Right, so here if I talk about offset, for 0 it is 4, for 2 it is 1, for 3, 1, 2, 3, yeah, this is fine. And positions are fine as well. And for this one the offset is this, so which is fine again. So I only need to consider those offsets where basically, you know, the number of elements are greater than n by 3. Right. So if size of I is less than n by 3, then I really can't do anything here, so I will have to continue. So I'll have this should be I.ss. So this will be the offset here, I.ff, and I'll just pass in the array here, and I'll also pass m and n. So this will be the offset here. So this is basically vals. Right. So now I need to find out a way to find the minimum number of swaps needed. So right, so just give me a minute here. So now I clearly just have to check if it is possible in M swaps or not. So let's just keep them as A and B. So A at I equals to ARR at I minus 1, and B at I equals to I plus offset modulo n. So let's keep them as vectors, it would be easier to debug then. Right, so let's do this. Okay, so I have just made a mistake here, this should be n. And what was M here basically? M was the number of swaps, right? Yeah. So here I have 1, 2, 0, 3, and I need to convert it to 0, 1, 2, 3. Okay. So I can just print the offset as well. So here the offset was 0, here the offset was 2. So we just shifted 2 of these elements, and here the offset was 3. Okay, so for the offset 3, it should be different, right? B at I plus offset. So this would be the position of the ith one, right? This is what I had to do. Okay, so here we've changed this. Yeah, so this seems fine. And I need to find out the minimum number of swaps needed now. Okay. Okay. Right, so if visited at I or A at I equals to B at I, then I don't need to do anything. Else, yeah, else I need to form a cycle here. So int length equals to, so I need to convert B to A, right? So head equals to B at I, right? Next equals to B at while next is not equal to head. So I just do length plus plus, this should be 1, and then I do right answer plus equals to length minus 1. So I just have to return if swaps is less than m unknown. Okay, I think there is an infinite loop here. Right. So if we are on 1 and So it actually needs to go to that place, right? So if we find that we are at 2, then we need to, okay, next is not equal to I. So head equals to B at I. This is where we are standing. Okay. Next equals to B at next. B at head. Right. So, okay. Now if this is equal to I, then I'm done. Otherwise, I just keep going forward. Okay. So let's just debug swaps here. Okay, I also need to do visited, right? Visited at I equals to true. Okay, instead I can do this. Visited at head equals to true. Yeah. And then I do visited at next equals to true as well. Okay, offset was 0 and we need to convert 1203 to 0123. So the swaps required were 3. But it should have been 2, right? So let's just debug the length here. Okay. Int length equals to 2, head equals to B at I. This is where we are standing. Okay. We need to convert B to A, right? So this should be A at I, not simple I. Okay. So we need to convert B to A. Okay. Now let's say I start on the very first index. I have a 2 and the required element is 0. So what do? I go to 2's place and I look for that element, right? So int head equals to B at I, while head is not equal to A at I. Right. So where do I need to go? Int length equals to 1. Okay. So I need to find the position of this number. Okay, let's just skip this part. Yeah, so we have 0, right? But we want a 1 here. Okay, so I have a 0, but I want a 1. So what I do is I go to ones place and I look for the number. Right. So I have a 0, but I want a 1. So I go to ones place and it says that I have a 1, but I need a 2. Okay. Hit while head is not equal to start. So I have BI, but I need AI, right? So while head is not equal to start, I am at 0, but at that very place, okay, so this is all about a cycle here. So I need to convert 0, 1, 2, 3 to 1, 2, 0, 3. So I am at 0, but we have a 1 here. So I look for the 1 here, right? Right, so I've stored the positions here. So I want AI, but I am at BI. Right. So I've visited this node. Head equals to, so I am at 0, but that tells me that I want to go for 1. Right. So I go here and I mark it visited. Okay, this is all running into an infinite loop because of a lot of confusion that I'm having. I want AI, I am standing at BI, right? So I mark this position as visited, and clearly head is not equal to start. So I do length plus plus and I do head equals to position of A at head. So it tells me to go to 2. Right, but head is only the position. I am at I, right? Right, so we need to search for this value in A array. So I have marked this as visited, and if A at A pointer is not equal to value, fine. So I do length plus plus, and then I need to move my B pointer. Right, so this is the B pointer, and okay, debug head, we don't need it. Okay, this seems to be working fine now. So I have 13103012. Yeah, this should be fine. Let me just test it once again. So I've made these groups by offset, and by doing this I'm only checking those groups of offsets where the number of elements are greater than n by 3, greater than or equal to n by 3, because m can be up till so much. And after that, yeah, for that I'm just checking here. This is the A array, this is the B array. I need to convert B to A. So I have stored the position of various elements in B here, and this is the visited part, this is the B pointer, this is the A pointer. So if they both are pointing to the same location, then we're done, and that we've already checked here. Apart from that, we need to get to value here in the A array, right? Yeah, so this should be fine. Let me submit it. Okay, great. Yeah, so this was again, I would say, a very cool problem here. And how much was the time limit here? Because I'm getting 483 milliseconds, so this should be fine. Okay. So we still have 51 minutes. I think I can just at least read this problem. Consisting of n distinct positive integers. Numbered from 1 to n. Define k as sum of okay. Where x mod y denotes the remainder when x is divided by y. We have to find and print p1, p2, so on up till pn. Okay, is there also some hacking going on here? Okay, so D has been hacked here. Okay, so D is actually getting hacked. So I won't get to know whether it is a TLE or. I think I can lock my D problem and look for hacks, maybe. Oh, okay, so the hacks are happening on the D problem. They're not happening on E problem. Okay, so I think, yeah, I can try some hacking here as well. Okay. Okay, so he has reversed them, which is fine. If x equals to m, then you break. This is fine as well. Oh, okay. Oh, but just a minute. Else he does I++. So if I have A, B, C, D, E, and what we want to form is A, B, C, D. But this will give a right answer in that case, right? Oh, I think this is wrong. Yeah, I think this is wrong. right? So this gives a no, right? And his solution will give a yes. Oh, okay, he's also doing this I++. Oh, I see. Which is actually making it, oh, okay. He was also doing that I++, which makes it fine. Let's look at this one. And yeah, let's look at the hacked solutions. Oh, we cannot look at the hacked solutions here. I am not able to understand what he's written here. Okay. So B is also getting hacked here. Oh, B is actually getting hacked. Okay. So what was this problem? Okay. What can't I look at this problem? Oh, so can I don't know. I am not able to see the problems. Oh, okay, I have to lock it, right? I have to lock the problem. Yeah, let me just lock A and B. Okay, now let's look at it. So what was this B problem? Yeah, we had to just basically form string B from string A. Okay, D is getting hacked. Hmm. This is very weird. This seems fine. Pos A is greater than equal to 0 and A at pos A. Okay, so this was hackable as well. Now I cannot look at the solution. Great. Right, so he's reversed both of these strings, which is fine. I did not reverse them, but I started iterating from back, so that's also fine. And then ps minus back. Yeah, I think this is fine. Yeah, this was fine as well. This I had tested on my own, so this was fine. Okay. If S1 at I equals to S2 at 0. Right. But he's trying out a lot of possibilities, I think, here. Okay, why can't I just copy this whole code? Okay, so he's trying out all possibilities first of all. Then he does flag equals to true. Int j equals to I plus 1. If s1 at j equals to C, break. Else you do j plus equals to 2. If j is greater than equal to s1 dot size, flag equals to false, break. Okay. But how is he maintaining that, the last part has to be even as well? So let's just, try out this as well. So just the fact that he's trying out all possibilities, this can result in a TLE. Okay. Okay, so this is giving a yes, right? Yes. Okay, so I think I found the test case that is not working for most of the solutions here. What they're doing is that they're not testing the last part, that it has to be even as well.